Hey, it's Mr. Allred here again, and we're going to talk about solving inequalities. We discussed what inequalities are, and now we're going to solve inequalities. So this means there'll probably be an x or something, and it'll have something attached to it that we need to get by itself. So keep in mind that what this means is we're trying to solve something that looks like, possibly in the smallest terms, x plus 5 is less than 3. So anything we do like this, we've got an order from the left to the right saying the left is always smaller than the right. And if we think back to equations similar to x plus 5 is equal to 3, we had a system for getting the x by itself. Well, that system is exactly the same. Okay, so remind you the steps we went through and talked about with solving equations. We talked about if there were fractions, we'd get rid of them, we'd get rid of parentheses, then we would collect like terms basically, and then we would get all our variables on one side and non-variables on the other, and then we divided both sides by a coefficient and we could check our answers. So the idea here is that we're keeping things balanced. With an equation, it was to keep the two sides equal. Here it's more to keep the things in an order. Okay, the small side is always the small side. There is one difference here, and it's one that's worth noting. If you multiply or divide both sides by a negative, you must flip the inequality symbol around. So basically, the reasoning behind this is that if you had something like 2 less than 5, which is a true statement, 2 is less than 5, and we could add the same number to both sides and the left would still be smaller than the right. Okay. But if we were to divide both sides by just even a -1 or multiply both sides by a -1, then we would have -2 and -5. Well, remember, if you walk to the negative side of the number line, -5 is actually smaller than -2. So when you change the sign of these two things, you change the order. So basically it takes you to the other side of the number line. So the way we handle that is if we did that, we would flip that inequality around. So just kind of keep that in mind. Okay. Everything else as far as solving equations will be the same. Solving inequalities will be the same. We just have to keep in mind that if we divide or multiply both sides by a negative, we're going to flip that around. So we're going to do some examples. So here we have 3x plus 5 is greater than 9x minus 12. So thinking about our equations, there's no fraction, there's no parentheses. So the next thing we try to do is get all our x terms on one side. So I might subtract x from both sides. And I'll try and get my non-x's on the other side. So I might subtract 5 from both sides. So when I clean that up, I have -6x greater than -17. Now, -6x greater than -17, I'm going to want to divide both sides by -6. Okay, so what that gives me down here will be x on one side and 17/6 on the other. But because I divided by this negative, I'm going to have to flip this inequality around. So it'll become x less than 17/6. Okay. So let's turn that into a number line and then a interval notation. So the number line will look like 0 in the center. 17/6 is a fraction, but it's positive, so it'll be to the right. So I want the numbers less than 17/6, so I want to go to the left of 17/6, so there'll be an arrow over here. And it's just less than, so it'll be a parentheses. And if I turn that into interval notation, parentheses, negative infinity, 17.6 parentheses. And if you did want to check this, you could pick any number that I have shaded here, anything less than 17.6, plug it in for the x, and see if the see if the left side is bigger than the right. It doesn't guarantee you did everything right, but it will catch some mistakes. Okay. Another example here, we got the fraction 5x plus 4 over 3 is less than x plus 7. So if I think about how to solve an equation, I really don't like fractions, so I'm going to multiply both sides by 3. So on the left-hand side, that cancels out the denominator and gives me 5x plus 4. And that's still less than, and now we'll multiply 3 on the other side, it'll be 3x plus 21. Then I'm going to work on getting, there's no parentheses, so now I'm going to work on getting all my x's to the left, because that's where I like them. So I'm going to subtract 3x from both sides, and I'm going to subtract 4 from both sides. Okay, so certain things cancel out. So when I clean up a little bit, I get 2x less than 17 again. How interesting. I'm going to divide by 2, but 2 is positive, so that doesn't change the order of things. So the 2's cancel out. That'd be x less than 17 halves. You can think about that as a decimal if you like. But because it was a positive 2 I divided by, I don't have to flip the inequality around. And I shouldn't. So number line, x in the middle, 17 halves, which is about 8.5, is to the right of it. X is less than that, so to the left of 17 halves. And parentheses, turn that into an interval. Parentheses, negative infinity, 17 halves, parentheses. And there we have all three forms. We have inequality, number line, and interval. One more example, and this is called a compound inequality. You see two inequalities here pushed together. If this shows up, hopefully your x is in the center. Because if it's on the edge, it's going to be kind of hard to get it where you want it. But this one is negative 3 is less than 4x plus 5 is less than or equal to 17. I must really like 17. The key here is always to get x by itself. First of all, there's no fractions, there's no parentheses, so we need to start getting the x to a side by itself. Well, the x is in the middle, and if I was to subtract 4x, I'd have a negative 4x on each side, and that would be good. So all my x's are together. So let's get the non-x's away from the x. So I'm going to subtract 5 from the center, but I want to maintain the order, so I'm going to decrease every part by 5. Okay. So when I do that, I get negative 8 less than 4x less than or equal to 12. And I'm still trying to get x by itself, so I'll divide everything by 4. So don't really worry about the ends as far as telling you what to do. Worry about the center if you have a compound inequality. So when I divide by 4, I get negative 2 less than x less than or equal to 3. So, hold on. Sorry, my PowerPoint went out there for a second, but let's see here if we're still going. So I was getting ready to draw the number line for this. So 0 in the center, negative 2 to the left, 3 to the right. So negative 2 is less than x, so that's a parentheses at negative 2, and we're moving to the bigger side all the way up to x is less than or equal to 3. So brackets and shade the middle region here. So in interval notation would be parentheses negative 2 up to 3 bracket, and that would let me do all three problems in all three forms.